In this lesson, I'll show you how to use chemical formulas as conversion factors. I'll show you 3 separate examples and we'll start with question 1. The question reads, hydrogen may potentially be used in the future as a fuel to replace gasoline. Most major automobile companies are developing vehicles that run on hydrogen. These cars are environmentally friendly because their only emission is water vapor. One way to obtain hydrogen for fuel is to use an emission-free energy source such as wind power to split hydrogen from water. The question is, what mass of hydrogen in grams does 1.00 gallons of water contain, where the density of water is 1.00 grams per milliliter? I want to start off by writing out the chemical formula for a water molecule, and we all know that it is H2O. Next, I'll find the molar mass of one molecule of water. And I can do that by taking the molar mass of each individual atom and multiplying it by the amount of atoms that are found in one molecule. So I'll take 1.008 grams per mole of hydrogen and multiply that by 2, and take 16.00 grams per mole of oxygen and multiply that by 1. And these numbers can be found on your periodic table. Using our calculator, you should end up with 18.016 when adding these two together. So let's write that down. We have 18.016 grams per mole. That is the molar mass of one molecule of water. Next, what I'll do is convert 1 gallon of water into liters. And the reason why I'm doing that is because they tell us the density of water. And from the density of water, we can find its mass in grams. So by converting gallons into liters and then subsequently converting liters into milliliters, I can multiply that volume by its density to give me the grams. Here's what I mean. I'm going to take 1.00 gallons of water, which is 3 significant figures, and multiply that by this conversion ratio. Notice that this conversion ratio can be manipulated in 2 ways. I could put gallons at the top, or I can put it at the bottom. I'm going to put gallons at the bottom, so 1 gallon at the bottom, and at the top I have 3.785 liters. The reason why I did it this way is so that this unit, which should read gallons, cancels out with this unit and we're left with liters. So 1 times this number gives us 3.785 liters. Like I mentioned earlier, I want to find out the milliliter equivalent of this number. And the conversion ratio for milliliters to liters isn't shown here, but it's very obvious that 1,000 milliliters is equal to 1 liter. So I'll multiply this by 1 liter at the bottom and 1,000 milliliters at the top. And the reason why I'm doing it this way is so that this unit cancels out with this unit, leaving us with milliliters. So 3.785 times 1,000 will give you 3,785. Now, one thing that I don't want you to forget moving forward is that we had 3 significant figures here. So our number should also have 3, so I'll put a dot underneath this 8 just to signify that that is the last important significant figure. Everything after that 8 is insignificant, but I'll carry that 5 just so that I won't run into rounding errors later on. So this is in milliliters, and now I'll multiply this by the density of water, grams per 1 milliliter. This will give me the amount of grams. This gives us 3.785 grams of water in 1 gallon. Now we will mesh these two numbers together. This is the reason why I found the molar mass at the beginning, because I need to multiply this mass with this number somehow. Now notice that this number is written with the grams at the top and the moles at the bottom, although it can be written in the opposite way. So I'll take 3.785 grams and multiply it by 1 mole at the top, and at the bottom I'll have 18.016 grams. And watch what happens. This will cancel out with the grams, and now I can find out how many moles of water exist in 1 gallon. Using my calculator, 3.785 divided by 18.016 gives me 210.09. 210.09 moles, and everything after this zero is insignificant. That is the amount of moles of water, but we're looking for the amount of grams of hydrogen. So what we have to do is take this number next, of 210.09, and multiply it by the following, where I have 2 times 1.008 grams per mole. This was the molar mass of hydrogen, 2 times the molar mass. And this unit will cancel out with this unit. Let's go ahead and see what happens if we plug this into our calculator. So this number times 2 times 1.008 gives us 423.54. 423.54 grams. Everything after this 3 is insignificant, although it's followed by a 5, and this number is odd, so this will go up by 1. We end up with 424 grams of hydrogen. Now, another way you could have figured this out was to find the percentage of hydrogen and multiply that percentage of hydrogen with the moles that you found for the water, and then convert that back into grams. Now, if you would like the answers to questions 2 and 3, make sure you watch part 2 of this video, where we continue our lesson on how to use chemical formulas as conversion factors. We'll see you soon.